Record. And Sandra, you can take it away.
Thank you, Megan. Good morning, everyone. Welcome to our webinar on sustainability challenges in manufacturing. My name is Sandra Enciso. I'm one of the project managers with the Energy and Sustainability Service Group within the Manufacturing Extension Partnership at Georgia Tech. I'm also the program manager for the Partnership for a Sustainable Georgia. Next slide, please. Before we begin, let me tell you a little bit more about our Partnership for a Sustainable Georgia. This is a United States Environmental Protection Agency initiative for the Region 4 that provides basic funds to support pollution prevention technical assistance within Georgia. The goal of this partnership is to help organizations like yourself across the state of Georgia to identify projects that lead to eliminate or reduce potential pollution, conserve energy, review water usages, and waste generation at the same time that achieve savings in operating costs. The members of this partnership include the Green Chamber of the South, Oakley Thorpe, and the Georgia Tech Manufacturing Extension Partnership. With the Green Chamber of the South, we are able to provide networking events to bring together businesses across the Southeast to promote sustainability and share best practices. With OPC, we provide energy and sustainability service to the customers at a heavily discounted rate in the state of Georgia. Next. EPA has defined prevention of pollution, or P2, as any practice or activity that eliminates, reduces, or prevents pollution at its source before it is created. So as shown on the EPA waste management hierarchy, P2, also known as source reduction, is fundamentally different and, where feasible, more desirable than recycling, treatment, or disposal. It is often cost-effective to prevent pollution from being created at its source than to pay for control mechanisms to treatment, equipment, and disposal of waste products. When less pollution is created, there are fewer impacts to human health and the environment. What are the benefits of P2? Among the organizations that have implemented P2 initiatives or projects, these are the main two outcomes as a result of that: increasing or improving efficiency in terms of energy, water, and material usage, as well as selection or identification of environmentally friendly materials or benign fuel sources. Overall, pollution prevention reduces both financial costs that are mainly related to waste management and cleanup expenses, and environmental costs related to health problems and environmental damages. Pollution prevention protects the environment by conserving and protecting the natural resources while improving or promoting economic growth through more efficient product or industries. Next. Who we are at Georgia Tech? The Georgia Manufacturing Extension Partnership, also known as Georgia MEP at Georgia Tech, is a state and federally funded economic development program, which is part of the MEP National Network. Our mission is to enhance the economic well-being of Georgia by helping manufacturers improve their performance in the global market. Next. As you can see in this graph, we have 10 regions throughout the state, with the regional manager living and working within each one. We also have over 30 project managers who live across the state, which means we have a Georgia MEP team member within a 2-hour drive of any manufacturer within Georgia. What we do at Georgia Tech, our project and regional managers are industry veterans and with real work experience who have worked and have led manufacturing companies. They provide expertise in many different aspects, as you can see in the slides, for manufacturing and businesses, including strategy, leadership development, process improvement, quality, energy and sustainability, which is the group I'm part of, marketing, technology implementation, cybersecurity, plant layout, supply chain, food quality and safety, and many more. Next. As I said, Georgia MEP is part of a MEP national network. It's a public and private partnership with centers in all 50 states and Puerto Rico, dedicated to serving small and medium-sized manufacturers. The goal of the network is to create a positive impact for manufacturing companies across the state, which means every company that we work with is surveyed to gauge our center's performance. Here on the slide, you can appreciate some of the impacts our clients have achieved last year with the help of our services. Being a part of the national network also allows us to collaborate with other centers to provide solutions or resources for almost any challenge a manufacturer may present these days. Today's speaker is Mr. Randy Green. He is the Group Director for the Energy and Sustainability Services within MEP at Georgia Tech. Some of the areas, his areas of expertise include energy and environmental management systems, environmental and energy assessments, sustainability performance tracking and analysis, energy and sustainability metrics and data analysis as well. He brings about 40 years of industrial energy system processes analysis and organization experience. He is a mechanical engineer from Georgia Tech and has an MBA from Georgia State University. With that, I leave you with Mr. Randy.
Thank you, Sandra. And you see my slides okay? I lost the border around my shared screen. I want to make sure what you're seeing is.
Yes.
So you see today's agenda.
I just froze it.
Tell me when you see the agenda screen.
I see the agenda screen, Randy.
Okay, thank you. So we want to talk about sustainability and in particular manufacturing. It's I think easy to understand the word, but what does that really mean when we think about a sustainable manufacturer? Most of our processes in this country today would not be considered completely sustainable, and we'll talk about what that means. We'll look at some strategies for improving sustainability. Certainly, if you are working in manufacturer and you're in a supply chain, or you have customers who operate on the global stage, there's probably some pressure in the marketplace already for you to do something in this arena. We'll try to give you a roadmap for how to at least move in that direction, and certainly we'll have a chance at the end for you to ask any questions that you might have that either we didn't cover or you just wanted more, you had more questions about some part of our talk today. So I do want to point out that you'll see a diverse set of characters in the graphic on this screen, and that's not by mistake. Each one really is relating to some part of the ecosystem or sustainability, you know, in the piece that they're holding. the point is that if we talk to 5 different people in this picture, or I were to actually poll around the room, of the virtual room today, we would probably get a different variation on what does it really mean to be sustainable. And so before we really dive into the impacts, the implications, and improving that for manufacturers, I thought we would take just a minute to understand what do we mean? What is the definition of sustainability? Well, the U.S. Environmental Protection Agency, which sponsors the P2 program that Sandra talked with you about, on their website says that sustainability is to create and maintain the conditions under which humans and nature can exist in productive harmony to support present and future generations. That is, what we do today leaves room and opportunity for future generations to at least have an equivalent lifestyle that we would enjoy today. The UN, which is really for many decades been pushing the banner of a sustainable world through its international presence. In 1987, and the Brundtland Commission defined sustainability as meeting the needs of the present without compromising the ability of future generations to meet their own needs. Very similar in some regards to what the EPA says. And if we just go to the dictionary, good old Merriam-Webster says, for sustainability, I love this. First definition is capable of being sustained. Well, that doesn't help us much. What does it mean to be sustained? And the next definition is of relating to or being a method of using a resource so that the resource is not depleted or permanently damaged. So in that, we get the concept that life could go on as we know it for indefinitely if we can achieve some sustainability in an activity or process that we're doing. And that's the implication here. But what does that mean for manufacturing? Because there's a lot of parts in a manufacturing process that the operations touch. So let's take a look at that right quick. So if I were to ask, if we had on the call today a startup in manufacturing, an entrepreneur that had a great idea for a new product and went out and put it into place, how would they define sustainability? I think that would be defined like this. In the end, the goal really is that you want to stay in business as a manufacturer. You want to satisfy your customers. You want to achieve profitability so that you have the financial resources to invest in tomorrow. But that takes resources and it takes other things as well. So, and that's, if you think about it, that's not a bad definition either. Certainly, we find that today there is pressure coming from, the global economy that we operate in, pressure from customers, from other markets, supply chains, and governments to be accountable within our manufacturing operations for some component or level of sustainability. My experience with manufacturers at this point is that they, in general, have not been really pushed to make this comprehensive or all complete. In general, there's usually just some reporting so that the supply chain can measure its impact to CO2 levels or measure the waste streams coming from the manufacturing process. But chances are you're in this webinar today because this is it's a current topic in your business discussions, and it's something that it has risen to the strategic priorities and considerations of most manufacturers, even that small entrepreneur that's just trying to stay in business. In general, if you go online and do a lot of research you will find sustainability divided into different pillars, sometimes they're called, or 3 areas. And if you think about the EPA, which is worried about the environment, certainly that's one measure of sustainability, how we're interacting with the planet and natural resources to ensure that, you know, future generations can meet their needs and take care of themselves. But there are also other parts of this sustainable framework that you'll find in the resources or text that you might read on sustainability. The others too being, of course, the social factor. You know, we interact with people. People are our customers. People are our employees. People are, you know, support. There are vendors and help to make things happen. So how do we interact with our employees? How do we interact with the broader community of individuals that our businesses operate in? And how do we do that sustainably? And of course, business is in business not to promote social activity or to enhance the environment necessarily. They're, you know, businesses are in business for an economic gain, for profit. So we're not going to be able to achieve social and environmental sustainability if the organization goes out of business. So there is some level of financial or economic sustainability associated with this concept as well. Certainly that's the one that your bank or maybe your stockholders are concerned about. Today, you know, we're going to focus on the aspects and the considerations related to environmental sustainability. I will tell you, we are not experts. You know, we certainly will have the strategic discussion with you about the implications of being socially sustainable or economically sustainable. And we have some resources in the MEP, but in general, our expertise lies in the processes and the systems that you employ for, you know, your manufacturing and their impact on the world around you and the planet as we know it. I will say that the United Nations has defined a strategy for sustainable development globally. They've named 17 sustainable development goals, and often referred to as the UN's SDGs. You can read more about these, and we'll certainly provide you a copy of this presentation if you're interested in the broader concepts related to sustainability with social and economic sustainability. You can read more there, but we're not going to talk about those today. So we have a manufacturing operation, and you know, I will say, I tell people this when I'm talking to them, tell manufacturers when I'm talking to them about their energy impacts or even their environmental impacts, their waste streams. It's like, you know, the most environmentally friendly state this operation can exist in is to shut the doors and go home. If you weren't doing anything, if there's no activity, then you wouldn't be creating any emissions or any waste or any other things that would impact with the environment. So, but that's not a sustainable strategy. You know, we need the jobs, we need the economies that come from, you know, the manufacturing that exist, and it's our mission here at the MEP to make that as strong and healthy as possible. And hopefully we can do that through a little of what we share today. But we have inputs, right? For any manufacturer, they don't exist in a vacuum. They exist in a real world, and they're trying to you know, make a product that satisfies a need in the marketplace. So they have raw materials or components. I mean, in general, whatever the inputs to your actual physical processes are, that's a need that you have in your business, and they come from some supply chain in the globe that's set up to generate that for you, whether it's a subassembly or a basic component like steel or kaolin or some element or mineral. And of course, nothing happens in the factory, even with the level of automation we have today, without people there to make it happen. If we just put raw materials in the factories, they're not smart enough yet to do everything on their own. So we need people. We need people to interact with those systems and those raw materials. And I realize I'm not telling you anything new. In addition, we need energy to make the things turn and move and heat and cool and all the processes that go on in manufacturing. And so I will say there's no scale or relevance to the size of these arrows here. It's really had more to do with convenience of holding the text for the label. But these would be the three main inputs for most manufacturing. But additionally, if we're talking about also the sustainability for the success of the business, it takes capital, it takes equipment, it takes, working capital to meet the needs of the business to do the other three functions that we see here in their process. Well, these are the inputs. Sustainability would imply that if we could use these completely without any waste or outputs, then we would be sustainable. And certainly our main focus in manufacturing are to take these inputs and produce products in our marketplace. But in doing that, we're going to produce waste. I've yet to go into a manufacturing facility, even the ones that claim to be zero landfill or net zero landfill, they still generate waste streams. They just have found a home that's outside of a landfill. So it's through some recycling or repurposing or some other method of removing the waste stream. But I've yet to go in a manufacturer that did not generate waste. And so this becomes part of our consideration for our environmental sustainability as well. In addition, we produce, excuse me. In addition, we produce emissions. We, have air emissions coming from the energy that we consume. We might have emissions from our processes. If we're painting, we might have VOCs and other compounds that evaporate or discharge into the atmosphere. And that, coupled with the waste, really become the biggest environmental impacts from our manufacturing operations. The other thing that we're beginning to see in this concept of sustainability is also the concept of life cycle. Excuse me. It's not just about what we produce, but it's about what happens to that product when it's at the end of its life. Does it have a purpose? Is there a way to reclaim or reuse the materials that are captured in those products without sending them to a landfill? And we're going to see more emphasis on this, as these concepts mature and develop. A couple of other things I want to mention while we have this here. Of course, the manufacturer exists to make a profit for its stockholders or its owners. There's equity. Certainly profits also flow back to the human resources or employees, through the payroll and other financial incentives that might exist in the organization. So as I mentioned, we're going to look at the environmental impacts related to sustainability. And what does that mean? We're not going to talk about the others, but I showed them here just for reference. But I will say, and Sandra mentioned this when she was describing the P2 program, if you do a better job of converting your raw material into products, or converting energy into products, or even capturing the human labor more efficiently, you generally will have less waste and less emissions. And the concept of being more sustainable also really is directly related to the concept of being more efficient. And generally, a more efficient operation has a net lower cost or relative lower cost per product. And so you're much more competitive in the marketplace. So we would make a strong push that you not just consider this as something you do to be socially responsible, but there is an opportunity in being sustainable to actually, be more competitive and have a better cost structure for your products and your markets. The other thing I want to mention before I leave this drawing or this graphic is if you think about our manufacturing operations, and we have a factory here with inputs and outputs, it's pretty clear what we do to impact the environment, with the waste streams and emissions and things like that. But what about just take the energy arrow here? Most organizations don't generate their energy on site. Electricity comes from a grid. So what about the emissions associated with that, the energy that you purchase? Or what about the emissions, both waste and otherwise, in the supply chain that provided your subassemblies or your raw materials or your component parts? So when you begin the discussion about sustainability, the manufacturer has to stop and ask, how far out do we push this scope or this boundary for which we're going to assume some commitment and responsibility for the sustainability of those processes? And it's an important consideration that you have to keep in mind when you think about this, because I could take let's take a factory that's making lawnmowers, and in the original design of that factory, they're stamping out the deck, they're painting or finishing it. They might be molding some plastic parts for the assembly, and then they assemble all these parts into a finished lawnmower and ship it out. And so they have energy impacts associated with molding plastic. There's a lot of environmental, both energy and otherwise, emissions associated with painting the deck and all that. So let's say they find a contractor or a sub-supplier, a supplier who will stamp out the deck and send it painted to the factory. So now the factory can claim they reduce their emissions, right? Because they're no longer painting or having to stamp metal decks. But the concept of sustainability doesn't let manufacturers outsource the impact from their activities. In general, you would still be accountable. So we have to think about the scope of our operations. What is it that we have farmed out to other organizations or other manufacturers to do for us? In particular, that's easy to identify for energy, and specifically related to energy and the emphasis on reducing greenhouse gases or CO2 equivalents is different scope levels, which have been defined within the UN framework for sustainable or for managing climate change. Let's look at those right quick, because this concept also applies to the waste streams that you generate as well. But scope 1 is generally considered, and you will hear this referred to if you look in the press or other discussions around sustainability. Scope 1 is the emissions directly coming from that factory. So if I were to think about the emissions coming from the factory stack, the waste coming out of the manufacturing process, those would be scope 1 emissions from the direct activities. But in general, most people recognize that there are a lot of indirect things that happen to support that manufacturing operation. The big one here would be what Georgia Power or the utility had to consume to deliver the kilowatts of electricity that the plant used to make the products. And so scope 2 would include those directly identifiable but indirect sources of emissions or waste. And then scope 3 really goes out beyond that. And it's captured better in their next slide. Let me show you this picture. So we can see in the center, you know, the energy that the company consumes on site, the natural gas, the gasoline and diesel fuel for vehicles, anything else that goes on would be considered a scope 1 emissions in the climate change protocol. But I would also say the framework for waste and other streams that you generate, there are waste streams that you generate directly from your process. It's raw materials, you know, scrap left over from that process. It could be packaging and other materials that you generated in receiving inventory and then shipping out finished products. Scope 2 would then be the other indirect things that you are associated with your process, such as energy. And scope 3 are then the incidental things that happen to support the other activities that you like, the travel that executives might make or salespeople might make. It doesn't necessarily have to be air travel. It could be you know, people are driving their cars to different functions or other meetings. Certainly raw material processing, or, you know, other products and materials and supplies that you need. So if you get involved in a discussion or you begin to try to have to answer questions, you know, for a major customer or supply chain, you certainly want to understand the scope, especially of your emissions, that they're focused on capturing from you. And in general, they would probably help you or give you some definition to help you identify what those are. But becoming truly sustainable is a major challenge facing manufacturing, really facing the, you know, global economies. We don't really have the technology today to replace all of the thermal processes, the fossil fuel processes. You think about steam and heating ovens, process and material heating that takes place in manufacturing. We can't electrify all of that. And if we did, you know, most of the grid is still not supplied by renewable fuels. And so just our ability to efficiently convert, you know, additive manufacturing is going to help us reduce waste of raw materials and things like that, certainly reduce the scrap. But we need a lot more innovation and technology to come down the pipeline. So the only point I'm making here is that we want to be as efficient as possible, but in the end, being truly sustainable so that we were not a net consumer of materials, or, you know, and we didn't leave a negative impact on the environment. We're not there yet. We can't make that happen just yet. Certainly, waste streams. You know, we find a lot of manufacturers who are really interested in reducing what they send to the landfill. It could be packaging materials, other miscellaneous waste coming from production. in the food industry, food manufacturing industry, food waste is a particular focus as well. But it's not easy. There are infrastructure issues with transportation and cost, the distance you are to recyclers. I actually just found out this week we have a recycling program in my community, and even though they pick up the recycling container here, it's all just going to the landfill because the municipality was upside down. It was actually costing them more to try and handle and process the recycled containers than they were getting in the recycling process. So I'm not sure what's going to happen with that, but there is a significant infrastructure issue associated with, trying to reduce landfill volumes and those capacities. And we need, again, better process technologies to more efficiently utilize the resources. And certainly the limitations of capital. Maybe we could be more renewable today, but we can't afford all the technology that it would take, for a 10% or 20% reduction. So it has to be balanced, certainly, with the economic survivability or sustainability of the organization. But alternative energy sources, alternative materials, or more advanced manufacturing techniques, they come with a price tag. And so all of these are really challenges to the manufacturing community when it comes to being able to truly say that you have a sustainable process in the manufacture of your products. But the big push, and I see this, there's actually several RFPs out right now to try and innovate in the industrial sector with electrification. How do we take all the heating applications and move them away from fossil fuels and put them on an electric energy supply, with the concept that we can generate electricity renewably? But that has its challenges. So this is the global picture, and this is available from the International Energy Agency, I think the IEA. You'll see that oil, coal, and natural gas account for, what's that, 67, roughly 70% of the global electricity generation. If you throw in nuclear, that's another 12.8. So that's, you're up to about 73% of the energy. Some people would consider nuclear renewable, some consider it not renewable because of the, the waste associated with the spent fuel. But that blue slice at 6.85, the green slice, the light blue slice, and the yellow slice, those would be considered renewable sources. So currently, we're only about 15%, roughly. The global electricity supply is only comes from about 15% of it comes from renewable generation. So if we were to electrify every car or truck tomorrow, we were to electrify every industrial process, how would we run the planet? And it creates a challenge. I'm curious to know, and I'm not going to take a poll today, but do you think the US would be behind or ahead if we were to look at this same map or this same graph chart for the US? I'll show you. So you'll see that we have reduced the percentage of electricity that comes from coal, but we've increased the amount of that energy coming from natural gas. And that's probably been the biggest conversion that's happened in the last 10 years. There's been very little growth in nuclear, but it's still a substantial part of the US profile. And so if we include oil, coal, and natural gas, we're just a little over 60% with that. If we throw in nuclear, we're at 87%. And our actual slice of renewable is even smaller than a planet, because one, hydro, which is the dark blue slice, that's a matter of geography and environmental considerations. You can't just build lakes anywhere and everywhere and have an opportunity for that. So we have a challenge in trying to be sustainable, in particular from an energy perspective. Something's going to have to happen in the grid for us to really be able to electrify, these industrial processes and transportation, for that matter. If we were to have to plug in every car in the US today, we don't have enough generation capacity to charge all those batteries. So there's a fundamental issue here, and we're really, to be honest with you, we're decades away and trillions of dollars away from being able to have a truly sustainable grid. But it doesn't mean we can't do something today, and that's the point I want to make, that we can, as manufacturers, make choices and operate more sustainably. And that's our encouragement today, is that just because we can't get all the way there doesn't mean we shouldn't start down this path. And as I mentioned earlier, in the end, it's a better operating mode for any manufacturer. In general, it's more efficient and more cost effective. So the greatest emphasis I've seen in the US has really come through the supply chain. It's large retailers or automotive companies pushing down into their supply chain, saying we want to account for the greenhouse gases associated with the products we sell or the components we put in our car. But they're also probing their suppliers or manufacturers for waste, making them report water use, waste use, the amount of recycled materials they use either in their product or their packaging, also reduce packaging. And I've seen a whole array of sustainability questionnaires or reporting that manufacturers are being required to do as part of some bigger supply chain. And it creates some extra needs and demands on manufacturers, but that's where I see the state kind of where this is today. So if you're in that state, or you just want to make a commitment to be more sustainable, how do we make that happen? And I told you we'd give you some steps or direction for that, and I'd like to share those with you next. So really the roadmap for, we would tell anyone, if you're starting down this path, the first thing to do is really understand where you are. If your big customer says, we want you to become more sustainable and we want you to start reporting your energy emissions and your other emissions and your waste streams, you got to figure out where you're starting from. And it's probably one of the biggest surprises for me is that manufacturers spend a lot of time looking at the other inputs to their process and then fail to effectively manage their impacts on the downstream side of all that. So trying to understand water use or air and water emissions and other waste streams associated with their management process. What are those? If I were to ask you today as a manufacturer, what is the conversion efficiency for your raw material or your components? What is your scrap rate? That you might know. But what's the energy intensity of your processes, or how many kilowatt hours does it take to make one unit of production? Peter Drucker said, if you can't measure it, you can't improve it. He's often quoted as saying, if you can't measure it, you can't manage it. But his actual quote was, you can't improve it. Well, if we want to improve sustainability, we've got to measure something. And I'll go on to say, because I see so many manufacturers who don't take the little bit of time that it takes to understand what those impacts are coming from their waste and emissions. Because if you don't measure it, you can't improve it. Maybe you can measure it, but if you don't, then you're still just as in the same spot you would be if you couldn't measure it. So the real starting place is know where you are, figure out what your waste streams are, what your emissions are. We help a lot of companies develop a carbon footprint so they know where their process opportunities are for reducing carbon, and the same would be true for your waste. You know, what parts of your process produce the most waste? How do you identify the opportunities for waste reduction and making your operation more sustainable? And in the process of doing that, you can then prioritize the systems, the processes, the parts of your operation that you want to begin trying to improve. And my last note there is, you know, this is not something for an environmental engineer or a sustainability expert to do. If you make it everyone's job, you'll be amazed at the contributions that, you know, your workforce can help you achieve in improving your sustainability. So if they know that reducing material waste or reducing landfill waste or you know, reducing your energy and carbon footprint would help you operate more efficiently and effectively and be more sustainable, I think they would be engaged with you. That's the general state that I find, is that most people would make that commitment and be involved. So I'm the next couple of slides, and we're just about finished. I wanted to share come from our actual energy footprint tool. This is if we did an energy assessment in your organization, we would first develop an energy balance. But the tool also shows us the carbon footprint for your processes, at least for the energy side of things. And we really promote this as a concept of really understand where you are to start, because so many people, the one thing I hear when people are challenged with trying to be more sustainable is they immediately want to know how much solar PV could they put in and what would it cost. They think about replacing their grid electricity with something they generate on site, and that's a valid strategy, but it's very expensive and usually not economically feasible. The other thing that they do is they gravitate to the things that are easy to understand. So if we replace all of our old style lighting with LEDs, we can reduce our carbon consumption for lighting. And I can tell you, most manufacturing facilities, if you got to 3 or 5% of your energy was for lighting, you'd be high. There's just not a, you know, you can work on those kinds of projects, but you're not going to make a huge dent in your carbon footprint or your emissions. So this kind of analysis really helps you identify and focus on the parts of your operations and facility that where you can get the most bang for your effort, and you can prioritize around the reductions. And there's more detail to see. These are the different parts of this manufacturing operation, but you can see that 2 of those are significantly the major contributors to their carbon footprint. In this example, we can see a little more granularly inside the actual systems that they have identified, the boilers being the most significant contributor of carbon, but then some other electric fired or electric sourced equipment. And in fact, everything else you see in that list would be electric. The interesting thing that is that 50% of the carbon in this example comes from those 2 sources. So if I can figure out how to improve either one of those by 10%, I'm going to do more. I can reduce my carbon more than if I turned all the lights off in this facility and totally didn't run them at all, let alone, you know, converting them to LED only saves a percentage of that. So the bigger impact here would be to focus on these top 10 sources of carbon and figure out how you could reduce those. You'll see compressed air is number 9. The U.S. Department of Energy estimates that 20% of all energy for compressed air is spent in leaks. And so if we could reduce that 20%, we would get about a 0.4% reduction in our carbon footprint. So there's a lot of opportunities in this Pareto kind of analysis, and it's really the best place to start, because then you're working smarter, not just, you're not just doing busy work that that has little benefit for your organization. In general, we would say, before you dive into really trying to develop renewables or do anything else in the alternative energy arena, whether it's buying credits or RECs or whatever, you should optimize your efficiency. Find the opportunity for making your processes as efficient as possible. If you're going to put in solar PV, why do I want to spend all that money and then have it supply uses in the factory that are inefficient or wasteful? And so the first place to start in any process for sustainability, especially on the energy side, is to focus on efficiency. And you'll see that it's gotten to be quite a popular topic in the press. Consider getting experts to help you identify opportunities for improvement. Sometimes these come at low or no cost. There's actually an industrial assessment center program that Georgia Tech, our group, runs for Georgia Tech. And if you qualify within the Department of Energy framework, you can get a free energy assessment. So if you think you're interested in that, I put the website here. You can go and look at that. You can read more about IAC as well. But we also do waste stream assessments or pollution prevention assessments. All those are helpful ways to kind of develop the footprint or the profile, so you know where the opportunities, the best opportunities are for improving your sustainability. The other thing I'd really like to challenge you with is the continual improvement framework that's captured in the ISO standards, the management system standards, which most of you are probably familiar with 9001, which is for quality. But there is an environmental standard and an energy management standard, and both of those provide a really good way for management to not just say we're going to become more sustainable, but give them a framework for actually including that in their decisions and their business strategies, and making a real impact through the continual improvement methodology applied to sustainability. And of course, this is in general what people come to us with, is like, help me figure out if I could put solar in, or help me figure out how, what are my options for buying green energy and things like that. Those are certainly worth considering, but only after you've done the others. You should really do some self-assessment and understand where you are. What's the real benefit of renewable options on site? Solar PV is a very popular one these days, but some of you may have the option for biomass, and in certain cases, even CHP might be considered combined heat and power, which is a whole nother topic we've done webinars on. I won't go into detail today, but you might, that might be a good option for you in helping you reduce your carbon footprint and other waste streams associated with your energy supply. In general, I would say most manufacturers that I talk with, and their corporate has set some goal for becoming carbon neutral or zero carbon by 2030 or 2050 or some horizon like that. The only way they see they can effectively do that, because of the technology and the hardware limitations that we have, is through the more financial instruments, or like buying green energy from their local utility, or purchasing renewable energy credits, or some type of carbon offsets, such as you're really paying some landowner to not cut the trees for the next 10 years, and you can take the benefit of the carbon that those trees would absorb from the atmosphere and offset your your generation. The harder challenge for me is on the waste stream side. There's still probably some infrastructure and technologies that need to develop to help us there. But in general, I would say if you start a conversation with your suppliers and your customers, especially around packaging and things like that, I've seen many manufacturing organizations, they might buy consumables for their manufacturing, whether it's associated with welding or painting or fasteners and things like that, and the packaging just gets sent to the landfill when maybe there's a way to convert to reusable packaging, so the packaging goes back to the vendor and gets refilled and resent back to the supplier. So, but you don't know till you have that conversation. So that's our recommendation for really trying to tackle those tough that part of sustainability. So this is the end of our talking points. I do want to say that I appreciate you taking the time to sit in with us today, and we'll certainly take any questions. We have 4 or 5 minutes left here. I don't know if you have any, but I appreciate your time in attending, and I hope it's been helpful. I hope you will call on us if you're challenged with any part of sustainability, understanding what that is. Please give us a call. We'd love to have that conversation and help you figure out how to move forward.
Thank you, Randy. Definitely, I found it very informative and very interesting. Please, if you have any questions for Randy or myself, feel free to unmute yourself and ask the question, or write it in the chat as well. So we have a couple of more minutes. We can stay here if you have questions.
So I have a question for you, Sandra. So did I have the right webinar topic on the last slide?
Yes, you do.
So I could go ahead and show that. We could talk about that.
Right. If you don't mind doing that. Well, I don't see any questions in the chat. As Megan said at the beginning of the webinar, okay, I think we got one question.
Mhm.
This webinar will be recorded and you will receive an email with the recording. So let me read the question. For SMEs, what guidance would you provide as resources are in plenty and ISO accreditations are quite costly?
Well, my answer to that would be to go back to, if you don't mind me backing up, is first know where you are. I got to go back more. Yeah. So just identify where you're starting, and then, you don't have to do any kind of ISO management system to do that. We can certainly help you with that, or you could do that on your own. But just understand what your level of impacts are, both from your energy and emissions and in other waste streams. And then ask the question, what's a good place to start? What can we work on? What can we improve? And, you don't have to be a rocket science to figure it out. If you just start the conversation, so, there will be ideas in that process. So if you have limited resources, this can still be done. It doesn't have to be too labor intensive or too expensive.
For sure. Thank you, Randy. Yeah, no, I agree. And I think that's what I've seen the most. Sometimes organizations don't know where they start. And I think just taking some time to identify a baseline to start working on it, it's a key. Also, when it comes to ISO management systems, I want to say that if it's not part of a specific requirements, organizations sometimes don't need to be certified, so
Right.
that will lesser the cost. But I will still encourage the application of the methodology, the PDCA model as a framework to identify those efficient opportunities for the companies. So thank you, Randy.
Well, thank you for the question.
So as you see here, our next webinar, it's on science-based targets initiatives, or SBTs, within your manufacturing organization. I will be presenting the webinar, and we hope to see you again on December 14th at 11:30. Thank you very much for your time and participation.
Yes, thank you, everyone. Thank you, Sandra. Thank you, Randy.
Thanks, Megan, and thank you, Sandra.
Thank you.